So as we discussed a little bit ago, so Archimedes approximated pi by using the circumference of regular polygons, inscribed and circumscribed. So he did them both within the circle and without, like around the circle as well. Yeah. It was fake, yeah. So it was fake, yeah. So he proved it wrong. All right, so the area of the circle can be approximated in the same way using the areas of regular polygons. Okay, so I kind of previewed the area of a regular polygon as 1/2 PA, so we kind of mentioned that. So the area of a circle, as you know, is going to be pi r squared. So it says find the area of a circle with a diameter of 18 inches. Well, we know how to do that. If our diameter is 18 inches, that means our radius is 9. So our area then is pi times 9 squared. So we get an area of 81 pi. So hopefully you guys have been doing this for a while. You know how to do basic ones like that. Our units would be inches squared because it is an area. So it says find the radius of a circle with an area of 67 pi. Well, if you have 67 is equal to pi r squared, you would take your 67 and divide out by the pi first. And then you'd have to get rid of that squared sign. So how do we get rid of a squared? Square root, right? The opposite. So we would put in the square root of 67 over pi. So when we do, we would get r is equal to 4.618 inches. Okay, so those are basic problems. I think you guys probably know how to solve those. Here are a little bit trickier. You know, it's funny, like real life problems, when you're in college and you're deciding what deals the best, you can use some math to help you. So it says which is better, so which gives you more pizza? 2 10-inch pizzas or 1 14-inch pizza? Any predictions? What do you guys think? 2 10 inches, because you're like, oh, 2 pizzas, that's more. We'll see. So if I do 2 10-inch pizzas, I would have 2 of the pi r squareds, and our radius then would be 5 for those. So we get 2 times pi times 25. So we end up getting 50 pi. So that's for our 2 10-inch pizzas. Okay, so if I did the 14-inch pizza, I only have one of them, and I'm doing pi times 14 divided by 2, so 7 squared. That's pretty close, though. It's 49 pi. So they're almost the same. So it says, well, what's a better deal? So let's say you have a 10-inch pizza for $7.99 and you have a 14-inch pizza for $9.99. Well, you can figure out how many dollars per square inch you have. So you would do that by doing like $7.99 divided by its area, which its area would be 25 pi. So when we do that, don't forget your parentheses along the bottom, right? We talked about that. Use $7.99 divided by parentheses 25 pi. And you end up getting 10 or 0.1017 and so on. What that works out to be is like 10 cents per square inch. Well, what about the other one then? If you have $9.99 and that other one is 14 inches, so it's pi times 7 squared, you end up getting $9.99 divided by 49 pi. And that ends up being 6 cents per square inch. So the better deal is the 14-inch pizza for $9.99. I know, you just tricky. All right, so the sector of a circle. So it says the region bounded by 2 radii of their circle and their intercepted arc. So a sector is going to be like kind of like a piece of a pie, like PIE. And you're like, ooh, I want to eat that piece of pizza. That's a sector. Okay. So I'm often going to ask you to find like the area of a sector, and it's going to be very similar to what we did before. Do you guys remember how we did arc length? So let's think about it. If I have the area of this circle is, let's say it was 5 inches here, so it's 25 pi. How would I get the area of half of it? I would divide by 2, right? How would I get the area of a quarter of that piece? I would divide by 4. And then Jacob Sager, how would I get the area if I had 50 degrees there? 50 divided by 360 times the area, 25 pi, right? Same concept. Okay, so it's exactly like that arc length. So when it says find the area of sector AB, I have 120 degrees out of 360. In other words, I have a third of the circle. And I multiply by pi times 42 squared. So my area of my circle. So if you want to write area of circle first, sometimes that helps. the area of the circle is pi times 42 squared. And then this other number, 120 over 360, is the fraction that you have. So we're going to do our 42 squared. Then I'm going to multiply by 120 over 360, in other words, 1/3. So I end up getting a total of 588 pi is my answer. And that would be in square inches. Okay, does that make sense? So our area of our sector is our angle. So I write theta over 360 multiplied by the area, which is pi r squared. So I don't know if I actually wrote the area in the last section, so let me go back to the last section. I would say the arc length corollary is our length ends up being theta over 360 times 2 pi r. So instead of using that ratio type thing, we can use that. So I need to go back. All right, so very similar for this formula. So this one's using pi r squared because it's talking about the area of a circle versus the length of a circle, 2 pi r, arc length. So find the area of the sector shown below. So on the first one, we have 60 degrees. Out of the whole thing, 360, and we're multiplying by pi times 12 squared. So again, make your calculator do all the work. 12 squared is 144, times 60 over 360 is 1/6. 1/6 of 144 is 24. So we end up getting 24 pi. Units, centimeters squared. Does it make sense? Do you guys get it? So the next one would be 130 over 360 multiplied by pi times 5 squared. This one I don't think works out as nice. So when we reduce out our fraction ends up being 325 over 36 and then pi. So sometimes they're not pretty. That one's not very pretty. And again, centimeters squared. Okay, do we feel pretty good with arc area of the sector? All right, so let's kind of skip down to number 4 then. So it says, find the area of the shaded region formed by an inscribed regular hexagon. Okay, so this is a little bit tricky. So if I'm finding the area of the shaded region, I need to first find the area of the circle. And then I need to subtract out that area of the hexagon. Do you guys see how we're kind of subtracting that out? So our area of our circle is pi times 10 squared. That's easy. That's 100 pi. Got that. Our area of our hexagon is a little bit harder. So remember when I showed you guys this, you guys were working with your partners, we drew in something called an apothegm. Whoops, I'm not going to draw a pass there. We're just going to draw it on the hexagon. Now a hexagon's nice because a hexagon ends up having an equilateral triangle. So this ends up being a 30, 60, 90 triangle there. So if I had 10 for this measurement, I'm going to have 5 and 5√3. So the area of this whole triangle down on the bottom, maybe I'll shade it in a certain color. So the area of this red triangle here ends up being base, which was 10, times height, which is 5√3, times 1/2. So the red triangle ends up being 1/2 base, which was 10, and then height, which is 5√3. So it's 25√3. So that means the area of the whole hexagon is 6 of those 25√3s. I think you guys had this exact problem earlier. So our answer then is 100 pi minus 150√3. And that's our answer. That's a number. I know that doesn't look nice to you guys. You guys always are like, oh, but what's the answer? That is the answer. 100 pi minus 150√3 is how we would leave that. That's the exact form. But if you guys wanted to find a decimal, you could put that in your calculator. So 100 pi minus 150√3, just make sure you use the pi button, and you could maybe do like approximately, and you could say 54.352. And that would be in centimeters squared. Does that make sense? Do you guys get that? Okay, I think that's the last one. Oh, maybe not. So we got a couple more of these area ones. So something like this. We have 3 circles within a big rectangle. Okay, so we would do the same thing. We're going to do that area of the rectangle minus the area of 3 circles. All right, so our area of our rectangle is going to be 16, 16, 16 across. Do you guys see how I got the 16? Again, you kind of swing that radius around. So if I take my 8 inches, I could put it here. Right? The 8 inches was my radius. So 16 is my diameter. So 3 of those 16s, what's that make? 16 times 3? 48, thanks. And then what about the height of this rectangle? What should it be? 16, right? So my area of my rectangle is just 48 times 16, which really isn't that hard, but sometimes people have a really hard time seeing, like, moving the radius around. Sarkis, you with me? So 48 times 16. Now my area of my 3 circles, I'm going to have 3 of the pi times r squareds. Well, our r's was 8, so I'm going to have 3 of those 8 squareds. Pi times 8 squared. So I'm going to have 48 times 16, oops, which is 768, minus 64 times 3 is 192 pi. And that's our answer. We can't combine our 768 and our 192 because we have a pi attached to the 192. But again, if you wanted to get an approximation, and a lot of geometry teachers will ask you to do this, they'll ask you to write the exact answer and the decimal approximation. We get 164.814 inches squared. All right, does this make sense? Do you guys get it? All right, so let's kind of look at the last one. So number 6. So it says a square is inscribed in a circle with radius of 10. Inscribed in the square is another circle. Find the area of the region between the square and the smaller circle. So basically it's asking for this little area right in here. Okay, so I'll shade it in. Okay, so it's a little weird. Okay, the original radius of this circle is 10. We want to know where to draw the radius so that it's helpful for all 3 of these pictures. Well, 2 of the pictures, I guess. 2 of the shapes. So here's where I'm going to draw the radius. Right there. That distance is 10. That's going to help us get the area of the square, because really all we need to do is find the area of the square minus the area of the small circle. All right, I'm going to draw on a triangle to help us with this square. Can you tell me any angles in this triangle? 90, right there. No? You're like, it has to be 60 and 30, right? It's 45 and 45. Okay, do we see why it's 45? Because it's 45. If I had another one over here, it would make that 90, right? Do you guys see here and here? Yeah, because it's a square. So we have a 45, 45, 90. These are the ones you guys hated when we first learned these two. See if you're better at them now.
No, I'm good now. We've been working on them.
You've been working on them? Can you find these 2 sides? You're like flipping back. We did this exact problem.
It's like
5√2. Good job, Austin. Because you got to multiply by √2 to get 10, right? So you're like, okay, it has to have a √2 to get rid of that √2. So √2 times √2 would give you the 2.
Yeah.
So it's 5√2 and 5√2. You could also write x and x and do Pythagorean theorem, but that takes longer. You guys got to know these 45, 45, 90s. So our area of our square then, so this was 5√2 right here, but what's this whole side? 10√2. It's 5√2 plus another 5√2. So the area of our square is 10√2 times itself 10√2. Do you guys know what that is? Look, you guys busting out your calculators. Nope. I know what you did though. Close. He says 400, not quite 400. 200, because the √2 times √2 becomes 2. The 100, or the 10 times 10 is 100, so we have 100 times 2. So yeah, we have 200 minus the area of the small circle. Oh man, the area of the small circle. Well, what's its radius? No, that was the big circle. Look at my picture. What is its radius? I drew it in blue. 5 root 2, yeah. So it's going to be pi times 5 root 2 squared. So now we go back to the 5 root 2 squared. What's 5 root 2 squared? All this math. It is 50, so 50 pi. So our answer is 200 minus 50 pi. So again, if you wanted a decimal approximation, you could put it in your calculator. So it's around 42.920. And then be inches squared. Okay, so one thing at a time. So if you're finding the area of like a shaded region, you have to subtract things out. Okay? All right.